So now I'll show you the general outline on how to tackle maximum or minimum value questions, right? So usually these questions come across as they give you a 3D shape or situation, and they give you a requirement, and you have to find the maximum volume. For example, I have this box, right? The base is a square, x and x, but the height is a different value, right? So these are all unknowns. I don't know any of them, but I give you a requirement. The TSA, the total surface area, must be 10. Okay, 10 cm squared or whatever, right? So now you have to find the maximum volume based on this and this, right? So if you think about it logically, all of these variables could change, right? But I'm still tied to this requirement. So if I change all of these, what's the maximum volume of the total box that would fit this requirement? With the total surface area is still 10, right? So that's how these questions are built. So let's see what we have to do. Step 1, always list out what you know, right? So based on the equation, we can conclude that the volume for this box is x times y, right? So v equals x squared y. So that's that. You can also say that TSA must be 10. So let's write out the equation for the total surface area, which is 4xy plus 2x based on this face plus this face plus this face, and etc. And then you know it must be equals to 10. So that's your information. So now you have these two parts of information. We'll see how we use them later on. Okay, so next you have to identify what you need. Okay, the question wants you to find the maximum volume, right? So I need V when dv dx equals to 0, because remember, at the maximum point, dv dx or dy dx equals to 0, right? And V is your y, so dv dx must be equals to 0 at the maximum point. So to do this, first I need to find dv dx. How do I find dv dx? Well, I just have to differentiate this, right? But as you can see, there's a problem here where there's two variables. This might be a little problem. So how do we solve this problem? We have to eliminate one unknown, right? So before you start to do this, always make sure you differentiate the correct equation, correct formula. If you differentiate the wrong one, you might not fit into this. You might get maximum surface area, but they want maximum volume. So always be sure, right? So as I was saying, eliminate one unknown from this equation to get this dv dx. So how do you do this? Well, they give you this requirement, right? 10, the surface area, is this formula. So if I just rearrange this like this, I find that y equals 5 over 2x minus x over 2. So now I can say that this y in this equation is equals to all of this in terms of x. So I will sub all of this into this y and expand it to find a larger equation, which is if I sub all this y into the original v equation, I get this, right? So now I have one unknown and it's solvable. So now I'll just differentiate it, right? I differentiate it, and remember that at the maximum point, dy dx equals to 0. So dv dx equals to 0, blah 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 equals to 0. Like now I can find the values of x, right? And now you just have to find x. So just rearrange this to find x. So that's the maximum x value, not the volume yet, right? So always look what the question wants. If the question asks find the maximum values of x, then that's the answer. But if I ask find the maximum volume in total, I have to sub back, okay, x into this equation, right? Or I can sub it into this equation because I only have one unknown, right? So sub back the value of x into here to find the maximum value of the volume. So that's that, right? Always look at the question requirements, okay? They might ask what are the maximum dimensions. So they'll ask what's the maximum dimensions. Well, you have to list out the values of x, values of this x, and the value of y, right? So you can say that the dimensions are this times this times this, right? And you can just find all of these just by subbing in the answers that you found from the previous ones, right? So this is how you tackle maximum or minimum value questions, right? So minimum value is the same, actually. You just it's also a turning point, so you have to use that, right? So you can always check if you get two answers of dy dx equals to 0, check which one is the maximum, which one is minimum by doing second order differentiation, all right? But usually it's not necessary because you only get one answer, right? So this is how you tackle maximum value questions.